Another type of probability that we want to know about is probability using simulation. Now, simulation is an experiment, often with computers, that allow researchers to find empirical probabilities. Simulations allow you to study situations that are impractical or even dangerous to create in real life, and often they save time and money. So for example, you want to know the probability that this building that you're building will survive a tsunami. Well, you can't experiment with that, so you can only run computer simulations or modeling simulations, things like that. Epidemiology also uses that. Epidemiologic models for COVID-19 spread, for example. That's all based on simulations. It has to be. That would be another example. Especially in early days of the COVID-19 crisis, we didn't know how fast it would spread. So you have epidemiological models. So epidemiology creates computer models, and then you kind of run different scenarios through those computer models and figure out different probabilities. So the probability of this many people being infected if we do this versus the probability of this many people being infected if we do that. It's all based on probability, and it's based on those computer models because you can't recreate that system over and over and over again. And it doesn't have to just be epidemiology. Think about computers, virus systems, right? So getting a computer virus in your system, what's the probability of that? What's the probability of the computer surviving, etc.? Any kind of viral spread. It can also just be because it's annoying and impractical. so if you want to toss a die 1,000,000 times, that would take you a while, but a computer can do it rather quickly. As a matter of fact, I have those 3 different dice simulators already brought up. This one will roll a die and flip a coin. This one will roll all sorts of different dice based on what you would like. Do you want to roll a d4, a d6, d8? Yes, there are different dice available to you. In particular to play a game called Dungeons and Dragons, but other reasons also. And this one can let you roll any kind of die you like. Well, not any kind, but all these different kinds of dice. You can roll them and say how many you want to roll and so on. So you can develop simulations that way. As a matter of fact, I have a simulation built for rolling these dice. So if you look at the one on your page, it's from this dice simulator. And I said that I wanted to roll it 10,000 times. So I clicked the little 10,000 button and poof, there we have it. So it ran through 10,000 rolls of dice. And that's the one we're answering questions about, but we'll use the piece on our paper here. All right, so how many sides are on the dice that are being rolled? So you can kind of see it from this little picture down here. That we're rolling 6-sided dice. We're in 6-sided dice or 6-sided dice. There we go. I guess we could just say 6 because it's just asking how many sides, so 6. How many dice are being rolled, that's determined over here. You can actually increase and decrease the number of dice you're going to roll, but we were rolling 2. Right there. How many rolls are simulated? Well, we rolled 10,000 times. It's right here. So 10,000. What do the x-axis numbers represent? That's a good question. So if we add these 2 dice right here, 5 plus 6 makes 11, which is this one right here. So it's doing the sum of the 2 dice. The sum of the 2 6-sided dice. What is the probability of obtaining a 10? Okay, so 10 was 874 out of the total. Now I know you might be thinking, oh, I've got to add all those numbers. No, you don't, because you know that that total is 10,000. So those numbers will all add up to 10,000. So it's 874 divided by 10,000. And if you wanted to, you could come up with a decimal for that. 874. If you're really remembering of your algebra, you might remember what this is going to be without even having to type it. But there you go. It's 0.0874. Either one. So that's an empirical probability, but it's based on the simulation. Now that leads us to one other type of probability, which is the subjective probability. All right, a subjective probability is a probability that expresses an opinion or degree of belief about how likely a particular event is to occur. A subjective probability is not obtained from an experiment nor a replicable event. So most of life's events, of course, are not repeatable, in which case subjective probability plays a part. It's perfectly legitimate to have a subjective probability. A lot of students think, oh, it's not legitimate. Essentially, it's an educated guess, but nevertheless, that might be the best that you can have. So subjective probability is educated guess. Not based on data and past experience, but based on just your life experience and just imagining things, right? You'll see, because now we're going to run through this example that will have you compare the three main types. Now, if you're thinking, what about simulation? Simulation is just a way to get empirical probability when you don't have real data, or real data would be impossible or impractical to gather. So the three types of probabilities are classical, empirical, and subjective. Now, a friend tells you that there's a 60% chance they will be attending Julie's party this weekend. Okay, so you can imagine that. Yeah, I got about a 60% chance of showing up. It's subjective. You're making an educated guess based on your life, but it's not based on data or anything like that. So that would be a subjective probability. The Red Cross in Jackson keeps track of the blood types of everyone that donates blood at Jackson College's monthly blood drives. They estimate that the chances that the next person to donate at the drive being type O negative is 8%. Now I actually contacted the Red Cross in Jackson because they do keep track. In particular, they keep track of O negative. They keep track of all the blood types, but O negative is the most important for them because that's the universal donor. That's the blood type that can go into anybody in case of an emergency. So that is empirical because they keep track of it. It's based on data. And of course, that's something that the Red Cross would keep track of. That's something they would need to know. The probability of rolling a sum of 7 or 11 on two six-sided dice, which is an automatic win in craps. So you might want to know, craps is a gambling game at casinos. Well, without any kind of data, if you're just imagining the two six-sided dice and you say, hey, it's 8 out of 36, that's classical because it's a gambling idea, but it's also based on pure logic. You did not actually roll the dice or even simulate rolling the dice. And then this is actually true, speaking of rolling the dice a million times. So John Edmund Carrick was a British mathematician. He was placed in a Nazi internment camp during World War II. So while he was interned, he tossed a coin 10,000 times and found the proportion of heads was 0.5067. So he actually did that. He had nothing better to do, and he's a mathematician, so he had a coin, and so he tossed it and recorded the number of heads that he got in 10,000 tosses. Amazing, right? So he's kind of famous. There's a Wikipedia page about him if you're interested. That is empirical. He's gathering data, right? He gathered data by tossing the coin. Oh, and if you like for the top one, if you want a reason, you can say an educated guess. That's why. Right? All right, one of my favorite things to watch when I just, I'm roaming around on television. Not that I roam on television anymore, but and now that there's the internet. But during the World Series of Poker, which is broadcast on ESPN2, one gambler is given an 88% chance of winning the hand, and the number is placed on screen by their name. This is a really fun thing to watch. So the there's a camera underneath the table, and so the camera can see what the player's cards are. And so what'll happen is after the cards are all dealt, it'll say next to each of the players' names their chance of winning the hand. It'll have little percentages next to them. That's completely classical. What's happening is the computer that they're using to run the sports show knows the chances of winning for each particular hand. It has it all based on logic and theory. And actually, professional poker players know those probabilities. So professional poker players very much study probabilities. They know all the probabilities based on logic. That's how they make their money. So, which is one of the reasons you never really want to play against a professional poker player, because they will win. They know the probabilities way better than you do. All right, a commentator on CNBC says that they think next year's employment rate will be 5.4%. This always cracks me up. This is on one of those, CNBC is the business channel. So it's all the corporate business channel. So it's all about, well, I think next year's unemployment rate will be 5.4%. Sure, blah, blah, blah. They're talking, right? It's talking heads. That is completely subjective. They're making educated guesses. And they've actually done a study that the ones that the commentators that are the most, they sound the most firm in what they're saying, are actually the most wrong. In general, their predictions are the least likely to come true. If they're super, super confident, super bombastic, and this is true not just for business, but for kind of all things. If they're super, well, this is what's going to happen, so-and-so will be sorry, blah, 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 those are the ones that are the least correct. There's a study about that. If you're interested, you can Google it.